Hi, so today we're going to be talking about kinetics. So, the factors that affect reaction rates are the nature of the reactants, definitely. So, some reactant molecules react more readily than others, depending on their states, their physical state. For example, two solids could not react very readily, but two aqueous solutions in a container could react very quickly. Chemical identity, oftentimes ions in solution can react quicker, just like I said before. So, the concentration of reactants is really important too because the more molecules that are present, the more collisions that occur. For example, in this picture over here, you see if this box was bigger or there were less molecules there, which would decrease the concentration, then there would not be as many collisions happening here. So the reaction proceeds faster because there's more collisions, so the rate is greater. Another important thing is temperature. So there's a saying, heat them up, speed them up. The faster the molecules move, the more collisions that occur, just like the similar idea to concentration, and therefore the rate is increased. So two other things that happen are that increase the reaction rate or change it is the surface area of the reactants. So the exposed surfaces increase the change of collisions between particles, hence the reaction should proceed at a much faster rate. So, for example, the reaction here, if this were happening, for example, in a tray, like a plate, it might react faster because there's more exposed surfaces between the particles, so the collisions might occur more frequently between the container and the particles themselves. So, adding an inert gas has no effect on the rate or equilibrium of the reaction, and it's not part of the reaction mechanism, which we'll get into a little bit later. So, orders. So, the only way you can determine orders is by laboratory data and algebraically, or by a mechanism, which we're going to talk about in another video. So, orders, zero order is when the change in the concentration in one reaction and another has no effect on the initial rate. First order is linear or direct, and the concentration doubles and the initial rate doubles. So it's a direct relationship between those. And second order is nonlinear, so that means it's not direct, and in this case it's a quadratic. So when concentration doubles, initial rate quadruples. So we're going to see that into action right here. So the order of concentration of A would be 0. This is because in runs 1 and 2, the initial concentration of A is kept constant at 1 molar, and the initial rate changes. So we know it actually doubles. So we know that it cannot be a rate order of 1 or 2 because when the concentration is changed, the rate changes, which would make it 0. So the order of B would be first order because when the molarity is changed from 1 to 2 molar in runs 1 and 2, the initial rate is doubled. So we know that that would be first order because it's a direct relationship. When that is doubled, the initial rate is doubled. So to find total order is pretty simple. You just add the orders of A and B, which is just 0 plus 1 is equal to first order. So how to determine the order of reaction by the time versus concentration graph. So this is a very common question in multiple choice or even some FRQs. So here is a concentration versus time graph. Zero order means that when time is increasing, the concentration is decreasing. So that's here. ln of A represents first order, and the slope would be negative k. So this is first order, and this is second order. So quickly about catalysts is another way that reaction rate can be changed. So catalyst, it increases the rate of a chemical reaction due to the participation of a substance. But this is a common misconception that it just is in the reaction and it's increasing the rate. Although it's not directly increasing the rate, it's changing the pathway of the reaction, which usually they work by lowering the activation energy needed for the reaction to proceed, so more collisions are successful and the reaction rate is increased. So a homogeneous catalyst is when the catalyst is the same phase as the reactants. That's pretty simple. And the opposite with the heterogeneous catalyst. They're different phases in the reactants. And these usually appear in the rate law because of their concentration affects the reaction. That's has to do with homogeneous catalysts. So enzymes are basically just proteins that catalyze reactions in certain mechanisms in living organisms. So That's all in this video. And next video, we're going to be talking about reaction mechanisms and determining order from those. Thanks for watching.